Our current example of DSM only contains a few elements. Now we are going to expand the model with more security knowledge relative to the set-top box domain. The secure data is a main security property and it's composed of the authorization one. These elements need to be extended to describe all the security aspects and important concerns. This information is essential for the purpose of the DSM, and the security domain experts should use all their acquired expertise to represent it. The system engineers and the developers will access to this knowledge in the final stages of the process to understand and fulfill the security requirements of the system. Starting with the authorization, one of the main threats is the elevation of privilege. We create a new instance and we describe all the details about this type of risk. With an impact from medium to high, the motivation of this threat is to exploit a design flaw or configuration oversight to gain elevated access to resources that are normally protected from an application or user. The objective is to obtain more privileges than intended in order to perform unauthorized actions in the threat environment of the operating system, and the type of risk is always active. Associated with this threat is a lowering attack. Described as trusted code, which elevates privileges from untrusted code belonging to a low privilege running application, and it assumes that the attack comes from a trusted application installed in a set-top box, establishing an active attack. The type of attackers for these are untrusted app. It means applications which are already present in a set-top box. The capacity of this entity is to exploit security flags. This internal attacker has a high knowledge about the system, and it has high access to the system resources with medium skills required to be completed. We switch to the secure data property. All the security knowledge about this element is going to be used by system engineers to deploy the realization and implementation of the solutions in the final architecture. Therefore, this data should be as complete as possible. We add a new derived security property, integrity. This element guarantees the accuracy and consistency of data, and it assures that the content cannot be modified undetectably. This internal property also belongs to the UMA.S author domain, and it is defined by the University of Malaga. We also have to link it with a domain element. This security property has specific threats like the data tampering. A malicious modification of data from its original form. From an active source in an operating system environment. With very high impact in the device, the motivation is to spoof the original identity of a high privilege application. There are two attacks associated to this threat. The first one is the interception of data. Described as the application modifies transmitted data in a device. This active attack assumes that it can access to data transmissions. This attack is usually executed by a malicious app. With the capacity to intercept data transmission in a device. This internal attacker has a high control of the system resources and requesting a high ability to be managed. The other attack associated to the integrity is the stored data manipulation. It is similar than the previous attack, but in this case, the application modifies stored data in a device. And the assumption is that it can access to stored data. The type of this attack is also internal because it is run in the set-top box itself. This attack can be executed by the same attacker type. Therefore, we link this instance with the malicious app too. Proceeding this way, the security elements can be shared to represent different concerns in the DSMs. For instance, several security properties can share threats, assumptions, or even other security properties. When the domain security expert ends the DSM designing process and the security knowledge is represented in the model, the next step is to search and locate the most proper solution for the included security properties. The repository contains security patterns, which they provide the mechanisms to deploy solutions and implementations in the system architecture. Therefore, we can find a solution for our composed security property. In the secure data solution, using the SecV2 contextual menu, we execute the import pattern action. The repository interface is open and all the available SecV2 patterns are listed. In the repository interface, we search the text secure data, obtaining the secure storage pattern. We can review the security pattern information and we can check some information, like the provided security properties. This concrete artifact provides all the required elements, offering authorization and storage integrity. It's a perfect match to provide a solution for the secure data property. Once we select the security pattern and we import it to our framework, the artifact is downloaded and attached to the solution element, and this pattern references the possible implementations of the security properties to be accessed in the development stage of the process. Now our DSM is completed. It contains security knowledge to understand the concepts and concerns of the elements and a reliable solution capable to deploy implementations in the architecture. We can save the DSM in a repository and let system engineers to use it in their system models. The model is validated again before the upload and then stored in the repository, indexed and catalogued in a database.